and welcome to my channel. Today we are going to talk about how can you make your own personalized robot to play the game Mastermind. If you remember from my previous videos, if you're new here, have a look in the link in the description below. You can find a video which I've done on Mastermind game, and we talk about how can you play always to be victorious. And it will probably also appear as a suggestion in the upper right hand corner of the video, and also the link is down below. So what the trick is to always use the rule of consistency when you're playing the game. So what is rule of consistency? Basically, when you're playing the game, it's very important to pay attention to the hints that you have received in your previous chances in the form of red and white dots. So once you're going to play your next chance, think about what are the hints saying. Keep that in mind before you pick the contenders for your next chance. Go to the link in the description down below and you will find a detailed, elaborate video basically explaining what I just told you in 30 seconds. So obviously in this video we will have a guest, and you know him from like multiple other videos that I have done. Hopefully all of them were done willingly. And now that I know him so well, I can conjure him up with a simple magic trick. So we have our guest, Vincent, here, and he's going to teach us how can we write a simple Python code to make our own robot to play. Actually, we're going to make two robots because they're going to play against each other, right?
Exactly right. So we will have one robot which will set the code, and the other robot will try to guess what the correct code is, and again based on the hints from these red and white dots.
Perfect. So Vincent has his own YouTube channel, which is way more famous. He has, I think, around 970 subscribers right now.
Yes.
So he's just 30 away from 1,000. So you should definitely go check it out, subscribe to it, so that he can get that 1,000 subscriber bar. He has lots of different videos on academic freedom. He talks about dinosaurs sometimes. He talks about several other different topics in French and in English. So do check it out and do subscribe. Don't forget me. Share the video, like it, subscribe it, and let's get to how to make our own personal robots. Let's go. So we have written the code in Jupyter Notebook in Python, and this is accessible using Anaconda platform.
Yes, for instance.
Okay, so let's dive right into the code. So first we start by importing some of the Python libraries. So here we've used random and iter tools.
Yeah, these are two Python libraries. The first one we need because we will want to use a random number generator, and the second one will be needed because we will want to generate lists of permutations of the possible characters in the Mastermind game. So then we go into the code proper. So here we just initialize a variable which will count the number of attempts that will have been made before the code is guessed. It's just a counter. Here we give the code the list of all possible characters in the Mastermind game. So if you watch the previous video, you will recognize the lion, the hippo, the bear, monkey, elephant, tiger. And also in the game instructions, Mastermind, it advises you when the game gets too easy for you that you can also leave one of the slots empty, so it becomes kind of like a seventh character, this empty slot. So here we just implemented that in the code.
Just to increase the complexity of the game, yeah.
Yeah, exactly. So these are just the characters which can be present in the code, and as a reminder, all of them can only be used a single time. There cannot be doubles or triples of the same character. So now from all these characters, we generate the possible combinations with 3 elements. So we do that with this command here. So we use a function which comes from this iter tools library. in the permutation. So it means that we are taking all the permutations comprising 3 out of these 7 characters. And so these are the possible codes which might be set by the code maker.
Mm-hmm. And we have 2 different methods of giving the code. So, right, in the first attempt, you can set the code.
Exactly.
As a human set, which is commented out here. And the other way would be that the robot that we are going to generate chooses the answer code or the solution code for you.
Yeah, exactly. So this is where we make use of this random number generator. So what we do here is that we look at how many possible permutations there are. 3 element permutations from these 7. So these are the possible codes. And so we generate a random integer that is between 0 and this number of the possible permutations minus 1. So we do that instead of taking it between 1 and the length, because it's just the Python indexing that starts at 0. This is a technicality. Also, maybe if you learn to program in C, the index of tables and such things starts with 0. In Python is the same. So we take a random integer from 0 to the length of the list of possible codes, minus 1. And then we go into the list of possible codes and we take the combination of 3 characters corresponding to that random integer. So that will be the code that is set by the code setter, is generated randomly by the computer.
So that will be the part where the robot 1 is actually doing its thing, and or it could be you if you want to be more active participant in this robotic gameplay. So you could be the one either choosing the code, or you could just give robot 1 total autonomy and they can choose the code for you. Really cool.
Yes, exactly right. So after that, we're going to enter really the heart of the code. So where the other robot, the one which is tasked with the guessing, will attempt to guess the code. So we will do that in a while loop for those of you who are familiar with coding. And the idea is that the guessing robot will try some combinations, and while this combination doesn't correspond to the answer code, we will go through the loop again and again. And just to enter the loop the first time, to initialize things, we just write this stupid values for the variable trial. Trial is what will contain at every round the attempt by the guessing robot. Just to enter the loop cleanly the first time, we're just initializing to stupid. So we know it's going to be different from answer. And so then we can enter this loop. And so what do we do? So while the robot hasn't found the answer, what happens? So first of all, we will increment the number of tries. So it started at 0. We had started it at 0 earlier. So when we enter the loop the first time, we enter our first attempt, and then second and third, etc. So we increment this variable number of tries. Okay, then again we will use this random number generator. So what do we do here? So the spirit of the code breaking by the robot is that the robot, which is guessing the code, at each step, at each round, it will keep and reconstruct really, but keep a list of answers of possible codes that are still allowed based on the information it has received so far.
So basically using the rule of consistency. Like checking all the hints that it has received previously and then removing them from the possible choices that it's going to make next.
Yeah, exactly. At every step, if based on the information that it just received, a combination cannot be the code, it will just exclude it from the list of possible answers. And it will keep that in its memory, which is its own way of implementing the rule of consistency. Yeah.
Mm-hmm.
So we just need, again, some random number generator, because the code, so the guessing robot will have in its memory a list of possible answers, but it will have to pick one at every round because it can only play one guess. So we use the same tool. We look at the length of the list of answers which are still possible, and we generate a random integer between 0 and that length minus 1.
Mm-hmm.
And we will thus pick from all possible answers one of them at random,
Mm-hmm.
which is one element of that list of possible answers, which has the index ID x,
Mm-hmm.
which was chosen randomly, and this the robot will play. It means it will choose it as its guess, and it will say, okay, this is my guess for this round.
Mm-hmm.
And then, okay, the code will display at which round we are. Is it the first try, second, etc.?
Mm-hmm.
And it will display which combination of 3 characters has been attempted here.
Mm-hmm.
So this is the guessing part.
Mm-hmm.
Now, to progress further in the game, the robot needs to receive feedback in the shape of these red and white dogs, as we remember from the previous video.
Yeah.
So, as a reminder, the red dogs will tell you if you have characters which are also present in the code and they are in the same position as in your guess.
Yeah, the correct position.
Mm-hmm.
Yeah.
Whereas white means your character is also present, but it's wrongly positioned as compared to the actual code solution.
Yeah.
Okay, so to count this, the number of red and white dogs, we start with red, which is slightly easier in my view. So you go through the 3 slots in the code, because there are 3 characters or 3 slots
Mm-hmm.
in the code. So this you do with the for loop, and so for each slot you compare your trial character to the answer character, and if they are equal, you add 1 red dog, and you start it from 0 red dogs, obviously. And so you do this just for slot 1, slot 2, slot 3, and then you have the number of red dogs, and the code here displays it because we wrote this line.
Mm-hmm. And this is relatively simple because, yeah, if it just equals it, it just gives you the answer.
Yeah, and you just really need to compare in the same position every time,
Yeah.
so it's...
Everything has to be same, yeah.
Mm-hmm. Okay, a little bit more complicated, not too much, is the white dogs. So here we need a double loop. So we will go through each slot in the trial, code. It's not really the code, but the guess. And each slot of the answer code. So I goes over the 3 slots of the trial, J goes through the 3 slots of the answer. And so now if there are 2 characters which are the same, but the slots positions are different, which we write as I different from J, then this means that in the game you get a white dog. So you increment the number of white dogs, which started again as at 0, obviously. And then just for ease of reading of what the code is doing, we will display the number of white dogs that were obtained at this round.
Mm-hmm.
Okay, so this is the hint. So there is the guess, now there is the feedback or the hint, if you will. And now the robot really needs to do the thinking. Because it cannot just guess randomly. It cannot only do that. It needs to, take the information from the dogs into account.
Mm-hmm.
So what it will do is that it will, as I briefly explained earlier, it will update its list of still allowed answers at every round.
Mm-hmm.
So at the very beginning of the game, the list of possible answers is just the list of all combinations, because the code guesser has no information at all. So from its point of view, it can be any combination, can be the code. Now, in every round, it will get information which will allow it to trim this list of possible answers. So how does it do that? So it will go through the list of answers which are still allowed. So at the beginning, it's all of them, but then it will become smaller and smaller. And for each of these possible answers, it will for a while, so to say, pretend that this possible answer is the actual code. And then you do the same thing. So you compare what you just guessed, which is trial, to the elements of the possible answers. And so you pretend that the possible answer is the code for a while, and you count the number of red dogs and white dogs that you would have obtained had this possible answer been the actual code. So this is what you do here, and the logic is the same. The for and if commands are the same. Okay, so now for each possible answer you have a number of, so to say, virtual red and white dogs. And so for this answer to still be possible, to not have been excluded now, you need for it to have generated the same number of red and white dogs than the code, which you don't know, but you know that if an answer is if a code is the correct one, it will generate the same number of red and white dogs at every time as the actual answer. So this you test here. So you need for each, for your possible answers, you go check, is the number of virtual red dogs, so to say, equals to the number of red dogs that you actually got with your guess? And is the number of white dogs actually equal to the number of white dogs generated by the real code that you don't see, but you see how many white and red dogs it generates? If these numbers, both of them, match, you will add or re-add this possible answer to your list of possible answers, which at every round you sort of restart from 0 here, but actually you keep track of it here. Possible answers stays. It keeps the result from the previous round here, and here it updates it at the end of the round.
Perfect.
Yeah. And so last thing is, this is also interesting information, pretty cool to know, because it's not something that usually human users will generate when they play the game, is at the end of every round, the code will tell you how many answers are still allowed, given all the information that has been obtained so far.
Awesome. All right. So should we give it a try?
Yes. Okay. So we're going to run it, and it runs very fast. But let's go through it step by step. So the guessing robot has to choose something at the beginning, like the rest of us.
So for now, you have set the robot 1 as the one who will choose the answer code.
Yeah, code was already generated by a robot.
And can we see that?
You could see it, but it would kind of spoil the surprise. But it's going to be revealed in the end what the code is. So we've run the code, and let's go through the tries. So the guessing robot was actually unlucky on the first try. It tried elephant in spot 1, then monkey and hippo. It actually didn't get any red or even white dogs. So it's all wrong.
Interesting.
Yeah. And just based on the counting, it determines that excludes many solutions, because only 24 are allowed already after that.
It's kind of good.
Yeah, it's actually interesting. Then, okay, so it plays tiger in spot 1, empty, which we had mentioned is a possible guess, and then lion in spot 3. And with that, much more positive feedback with 1 red dog and 2 white dogs. So, and based on this, it now determines that it has 3 possible answers remaining. Then what it's trying is, well, of course it has to try the same 3 because it got 3 dogs. So it tries lion, empty, tiger. And this time only 3 white dogs, meaning none of the characters are in the correct position. And the code determines that means 2 answers are still possible. Let's see if it gets the correct one next time around. Yes, it was lucky. So now it has played tiger, lion, empty. And yeah, that's the answer. So it took it 4 attempts to get to the code.
It's almost like as if you were playing the game, but it's much faster.
It's much faster.
Yeah, definitely.
Would you like to set your own code and see how many tries the computer needs to break it?
Give it a try.
Okay, so let's see. What do we want to set? We will need to comment these 2 lines because we want to set our own human-made code. And now the answer, we will just type it ourselves. What do we fancy?
That looks
Lion,
fine.
hippo, bear is fair enough.
Sure.
Okay, then let's see. So let's see what our computer got this time. So a little bit luckier on the first attempt. It got the hippo right in the right position, no less. Getting 1 red dog, but nothing else, correct? So trimming down the list of possible answers to 36. And yes, on the second try, still putting the hippo in the middle, getting 1 red dog, but nothing else.
Yep.
So now there are only 6 possible answers already. So on the third try, it's getting 1 red dog and 2 white dogs. And now, even though it didn't get the code, you see that it's already determined that there's only 1 possible answer remaining. So it's going to guess it right for sure the next time around. And yeah, there it goes, guessing it correctly on the 4th attempt.
That's the code, basically. Yeah.
That's the code.
So you've got 2 robots.
Yeah, we got 2 robots. So as we said, one of them sets the code, but you can deactivate it if you would like to set the code yourself. The other one guesses the code and yeah, just in a way that is, well, has similarities with a human player, but surely faster, first of all, and also more systematic. Because I think when a human person will play is that you will consider the information you've received so far, you will try to think of a combination, and then you will say, okay, is it consistent with what I got so far, or is it not? If it is, you might want to try it. Whereas the computer will know for sure every combination, because it's very easy for it to keep track of many combinations. So it knows every combination that is still allowed. It tries one at random and it sees what feedback it got. Yeah.
And we can try to put that code on the drive and put its link in the description below if somebody wants to copy it, improve it, make their own version of it.
Yeah, sounds good.
So thank you so much for watching this video. I hope you have fun and you enjoy watching this video and learn something about how to code your own game and make your own personal robot.
So if you have any further questions or maybe comments or suggestions on how to improve the code, you're welcome to put it in the comment section down below, or even on my channel if you would like.
So we can probably improve the code further. Of course, there are multiple ways to improve the code and even make an online mastermind perhaps.
Would be a cool idea.
Definitely. Don't forget to like, subscribe and share the video with all of your friends and enemies. Doesn't matter. Don't forget to go to Vincent's channel and also give him a subscribe. He is 30 subscribers away. So close. So have fun, stay safe, and I will see you very soon. Bye bye.